Welcome to this session. Here I am going to present a presentation on types of faults and harmful effect of fault short circuit current. Here I am dividing my session into many parts. In first part I am going to give a discussion on normal operating condition in the power system, and second I will discuss on abnormal operating condition in the power system, and third I'll discuss on causes and effects of abnormal operating conditions. Next I am going to discuss on fault and its causes classification, and next I'll discuss on classification of faults, and then effects of faults, that is harmful effect of short circuit current. First we will see normal conditions in the power system. What are all the things that are comes under normal conditions? First we will say about rated current of the system. Next, voltage should be within the limits, and synchronism, that is frequency, is within the limit, and balance currents. Here for example, if we consider a generator has its rated current and its voltage, and it should be in a synchronism, and it should have a balanced current. And consider a bus bar should have a current of, for example, it should have a current of 50, 500 amps, 1000 amps, like that, in a large power system network, and the voltage should be within the limit, and like that. And consider a transformer. In the transformer it should be a voltage of primary voltage, and the secondary voltage should be within the limits. Next we will see what are the abnormal condition or which causes a faults, which is caused by, which is classified as a faults. Abnormal condition which is classified as a faults. One is a infinitely large current, and another one is a zero current, and over voltages, loss of synchronism, and unbalanced current. Let us see one by one what are those and what are the conditions at which it occurs. First one, infinitely large current. Causes are, let us take a transmission line, three-phase transmission line or a distribution line. Here here in the figure there is a short circuit between Y phase and the earth conductor, and there is a short circuit between B phase and a neutral conductor, and there is a short circuit between R phase and a Y phase conductor. These are all the conditions which are caused when there is a wooden or a tree branches falling on the transmission line, or there is a bird which touches on the transmission line. These are the conditions. Here all the categories are there in this one, that is phase to phase fault, phase to neutral fault, phase to earth fault. All the types of faults are present in this case, which leads to infinitely large current. Next, zero current. Consider a transmission line. Once again we are considering a transmission line. Here in this figure, R is a phase. That phase is open here. Because of that open state, that current, R phase current is zero. And here along with that there is a short circuit between R phase and earth phase. This is also due to the broken conductor and a joint failure. This is causes when there is a mechanical damage on the conductor, and there is a breakage of joints. Next, loss of synchronism. Here consider this is a generator. There are three generator circuit breakers. This is a generator bus bar, and this is a transformer circuit breaker, which is on the low voltage side. This is a transformer, and this is a circuit breaker on the high voltage side. This is a bus bar, and this is a circuit breaker, and these are the transmission lines. And there is another end, there is a circuit breaker, and this bus bar is connected to the load. This is a power system network, wherein which there is all of them are synchronism. Let us see under what condition they loses its synchronism. First, these are all under synchronism. First, we will see at what condition they lose its synchronism. First, there is a opening of the line. This leads to loss of synchronism. This may give rise to the voltage, or there may be a increase in the or decrease in the speed of the generator, because the load may be removed in this case. And second one, there is a removal of the load. Sudden removal of the load may be cause a rise in the voltage, and there is a removal of the circuit breaker. Here in this is open. This also causes a loss in synchronism, and then there is a removal of the circuit breaker, which is on the high voltage side of the transformer. This also causes a loss of synchronism. There is a removal of the circuit breaker at the generator side. This also loses its synchronism. Here, these are all the cases under which the generator loses its synchronism. There will be a out of operation. Next, loss of synchronism. Therefore, due to that, generator 1 and generator 3 are in this synchronism, and 2 and 4 are out of synchronism. Next, we will see unbalanced current. Let us see what are all the conditions under which there is an unbalanced current. Unbalanced current is going to occur when there is a open in the any one of the phases. That is shown in the figure. In this figure, R phase is open. That is, this is at a zero current. Because of that, one phase is at zero current, and remaining phase are the other current levels. This causes a unbalanced currents. During that condition, there is a R phase touches the earth. This may be due to the broken conductor or a joint failure. During this condition, the other phase voltage increases, and which gives rise to a negative or a zero sequence current. Next, there is a lightning surge. Which also gives rise to a fault in the power system. Consider two transmission tower. These towers are connected by means of a transmission line, and there is a cloud nearer to the transmission line. This will discharge us through the transmission line. This causes a lightning surge. This is one of the fault. Next, we will see a switching surge. This causes a fault. Consider the previous power system network, wherein which there is a reactor that is connected in this. This reactor is connected in order to limit the short circuit current. Because of this reactor, we may use a circuit breaker of a lower rating. Here, the reactor may be removed. This removal of the reactor may be causes a switching surge, and removal of the circuit breaker on the high voltage side of the transformer. This also gives rise to switching surge, and there is a sudden close of the reactor that also causes the switching surge, and sudden close of the circuit breaker at the transformer end causes switching surge, and removal of the load, this is also causes a switching surge. And another type of fault is a over voltage fault. Over voltage causes fault caused due to the over voltage. Over voltage is of two types. One is a internally caused over voltage, and another one is a externally caused over voltage. Externally caused over voltage occurs on these switch equipments which are situated at the outdoor. This is due to the direct lightning stroke. This is on the outdoor substation or the equipment which are placed on the outdoor, on which there is a direct lightning stroke. Because of that, there is a over voltage occurs on such an equipment which are present at the outdoor. Next, internal over voltage. This is present in the indoor power system equipment. This causes due to the switching over voltage and the switching operation. During switching operation, this may cause. Next, we will see what you mean by a fault. Fault is an abnormal condition. One is it is due to the breakage of the insulator, or it is due to the diversion of the intended path. Diversion of the current from its intended path. Let us see breakage of the insulation or a insulation failure. Over voltage due to lightning or a switching. So this is occur on the equipment which are present at the outdoor. Here there is a insulation flashover and a reduction of a insulation resistance. Such a type of condition occur in the power system. The power system, when there is a, for example, consider equipment which are placed in a cement industry. There is a cement dust and soot are accumulated over the surface of the equipments. This causes a reduction in the resistance of the insulation. This causes a flashover of the insulator. And there is another cause of the insulation failure is a breaking or a puncture of the insulator. This is occur, that is also due to the leakage of the circuit element. Next, conduction path failure, that is due to falling of the conducting object and the broken conductor or a joint failure or unbalanced current. This is mainly there is an alteration in the current of the power system. When there is a falling of the conductor or object, that is when there is a possibility of falling of a tree branches in the rainy season on the transmission line or a distribution line, that causes a fault. Those faults are line to line fault, single line to ground fault, double line to ground fault, three phase to ground fault, three phase fault. Broken conductor. Broken conductor means open circuit fault that is occur on the power system. Here one conductor may open, two conductor may open, or a three conductor may open. This is also called as a joint failure. Next, unbalanced system. Unbalanced system occurs, that is due to the opening of the one of the phase or there is a short circuit of one of the phase, or there is a earthing of the one of the phase. This is causes a unbalanced system current. The conducting path failure. Conducting path failure means flow of current is diverted from the normal path. Next, one phase open. Here in the diagram shown, R phase is open. Because of that, R phase current is 0. Here along with that, there is a short circuit between R phase and earth. This is due to the broken phase and falling to ground or falling of an object. Next, conduction between two phases. Here consider a transmission line that is abbreviated by RYB, three-phase transmission line abbreviated by RYB. Here there is a fault between R and Y phase, and fault between Y and B phase, and fault between R and B phase. Here such a fault occur due to the falling of a tree branch on the transmission line or a distribution line, or a bird touches the transmission line, during which one phase current get reversed. Due to that, there is a reversal magnetic flux going to get reversed, that will affect the performance of the system. Next, conduction between two phases and the ground. Here there is a transmission, here there is a distribution network is shown in this figure. Here there is a fault between Y phase to B phase, and again that is connected to the earth. It is a line to line, double line to ground fault. This is also called as double line to ground fault. This is also caused by falling of a tree branch on the conductor, transmission line or a distribution line. Next, conducting of all the three phases. This is called as a three-phase fault. This is one of the symmetrical fault occur on the transmission line. This is also due to the falling of the conducting object on the transmission line, that is a tree or a bird which touches the three phases. Or this is also called occur due to the lightning stroke. Next, to conduction of all the three phases to ground. This is one of the unsymmetrical fault. Symmetrical fault, sorry, this is one of the symmetrical. This conduction of all the three phases to ground, falling of tree branch or a lightning stroke. Next, classification of fault. Faults are classified into two categories. One is a symmetrical fault and another one is a unsymmetrical fault. Unsymmetrical faults are of three types: single line to ground fault, and line to line fault, and double line to ground fault. Double line to ground fault and a line to line fault. And a symmetrical fault. Symmetrical fault are of two types: three-phase fault and a three-phase to ground fault. These are categorized according to the falling of a tree branches or this on the transmission line. These are majorly occur on a transmission or a distribution line. These are the faults which are occur on a transmission and a distribution line. Next, there is a figure which shows a firing of a transformer. This is one of the harmful effect of short circuit current. Due to the short circuit current, heavy current flow through the network. Because of the heavy current, it will get overheated. Because of that overheat, there is a fire or a explosion. Because of that, there is a explosion of the transformer in the substation or a receiving station or a MVSS. This is the one of the harmful effect of short circuit current. Next, power cut. What do you mean by power cut? That there is a no power supplied to the consumer premises or the system. Power cut to the power system. That means there is no supply to the load. Load current is zero. That is called as a power cut. Here there is a diagram wherein which transformer winding is melted. That is, transformer winding is damaged. This is due to short circuit current. This is one of the harmful effect of short circuit current, that is going to damage the power system equipment. Next we will see another other effect of short circuit current. One, it damage the other part, that is caused due to overheating, and it may give rise to considerable reduction in the healthy voltages of the feeder, and there is a remarkable reduction in the voltage which gives rise to the protective relay coil failure and low voltage effect in the industrial motor. These are the harmful effect of short circuit current. Dear students, along with this, let us discuss some of the multiple choice questions that may be frequently asked. Let us first we will look at the question. Here the rating of the circuit breaker are generally decided on the basis of the multiple answers are unsymmetrical fault current, symmetrical fault current, normal circuit current, and none of the above. Circuit breakers are used in order to break the circuit under fault condition. Therefore, normal circuit current is not one of the among the answer. This is not applicable. Let us see among the symmetrical fault current and fault current. Under symmetrical fault current, all the phase currents are not symmetrically in nature. All the phase currents are unbalanced. Therefore, that will not give rise to a calculation of breaker rating. Therefore, only the thing that is left behind is a symmetrical fault current calculation. This gives rise to the rating of the circuit breaker that we are going to decide in order to safeguard our power system equipment. Therefore, solution here in this case is a symmetrical fault current. Next we will see another question, that is the most common fault on the overhead transmission line. Most common fault. One is a single line to ground fault, and a three-phase short circuit current fault, and a double line to ground fault, line to line fault. Here consider among this the major most common is a single line to ground fault. This is the most common fault when compared to the other faults in the power system. Therefore, single line to ground fault is a common fault that occurs on a overhead transmission line. Next, reactors are used at a various location in the power system too. Why reactors are used? Reactors are used to limit the short circuit current that I have mentioned in the lecture. Therefore, that is the answer. Straight away we can select that answer. Remaining answer, let us see what are the remaining answers that are present here in this case. That is the increase short circuit current, avoid short circuit current, limit short circuit current, none of the above. Among them, these reactors are the one which are connected in series with a circuit to limit the short circuit current. That you should remember. That this is limit the short circuit current. Next question is the most severe fault in the power system. Which is the most severe fault which gives rise to a large faulty current? Among them, this is in the line to line fault current. Consider a fault current among here in order to decide that we have to consider the fault current in the all the cases. In here, in the single phase, three phases are short circuited. In that case, fault current is most high, very high. In the three phase short circuit fault, the fault current is very high. Therefore, this is the most severe fault in the power system when compared to the other fault, that is line to line fault, double line to ground fault, and single line to ground fault. Answer is three phase short circuit. Next, when all the three phases are short circuited, the current to the system is, one is 0, low, very large, none of the above. In this, all phases short circuited, 0 is not the answer, and low is also not the answer, because all phases are short circuited. Current is not 0. Current is 0 only when there is a open circuit. Current is low only when there is a single line to ground fault. Current is very large here in this case, and none of the above. Here in this case, the answer is current is very large, because of there is a three phase short circuit. Next, let us consider the another multiple choice question, that is a reactor are connected with a system. In what way? I mean, what way we have connecting the system? First we have to see for what we are connecting the reactor. First, the reactors are connected to limit the short circuit current. For that purpose, to limit the current, we have to connect in series. Therefore, the answer is in series, in parallel, series, parallel, none of the above. Among them, there is a answer is a series. In series, we have to connect a reactor in order to limit the short circuit current. Because of that, we can also reduce the rating of the circuit breaker. The rating of the circuit breaker may also be reduced, because there is a reactor in this reactor is also there in this system. Next, when a short circuit occur in the power system, which of the statement is true? Short circuit condition. Under short circuit condition, what are all the statements that are going to be there? Voltage at the fault point is 0. Short circuit voltage is 0. That is correct. Next, very large current flow in the power system. That is also correct. And next, it result in overheating of the equipment. That is also correct. And the last option is all the above. That is the answer. Next, the fault on the power system that gives rise to symmetrical fault current is that is clear in the earlier discussion. That is a three-phase short circuit fault is a fault that gives rise to a symmetrical fault current. That is the answer. Three-phase short circuit fault. Next, we will see the use of reactor permit the installation circuit breaker of. What it will do? What the reactor will do? It will limit the short circuit current. Because of it limiting the short circuit current, obviously the current circuit breaker rating also gets lowered. Some of the options are lower rating, same rating, higher rating, none of the above. Among that, the answer is lower rating, because it will limit the short circuit current. Short circuit current get reduced. Because of that short circuit current is reduced, automatically circuit breaker rating is also get reduced. And other question, a short circuit may lead to, what are the things that will lead to? Short circuit lead to excessive current, that is right. then it lead to fire or a explosion, that is also right, and then that it leads to low voltage in the power system. Okay, then all the above, that means among this all are right, therefore our option is all of the above, that is the final answer. Yes, in this session we have discussed about types of faults and the harmful effect of short circuit current. Thank you.